7250. A standby source of fuel to an engine in a powered parachute is typically A. From an electrically powered pump. B. Through gravity feed. C. From a pressurized fuel tank. The correct answer is A. A standby source of fuel to an engine in a powered parachute is typically from an electrically powered pump. Powered parachutes, also known as PPCs, are lightweight aircraft equipped with a parachute-like wing and a motorized propeller system. The engine of a powered parachute requires a continuous supply of fuel to operate effectively. In the event of a failure or interruption in the primary fuel system, a standby or auxiliary source of fuel becomes necessary to sustain engine operation. 7249. The purpose of the fuel tank vent system is to A. Remove dangerous vapors from the aircraft and prevent an explosion. B. Allow air to enter the tank as fuel is consumed. C. Ensure a proper fuel-to-air ratio. The correct answer is B. The purpose of the fuel tank vent system is to allow air to enter the tank as fuel is consumed. In an aircraft's fuel system, fuel is stored in tanks that are typically sealed to prevent leakage and maintain the integrity of the fuel. As fuel is consumed by the engine during flight, the volume inside the fuel tanks decreases. Without a means for air to enter the tanks and replace the consumed fuel, a vacuum could form, which would impede the flow of fuel and potentially lead to fuel starvation. The fuel tank vent system is designed to address this issue by providing a passage for air to enter the tanks. It consists of a vent line or vent valve that allows atmospheric air to enter the tanks as fuel is consumed. The vent line or valve is usually positioned at the top of the tank, allowing air to enter while preventing fuel or fuel vapors from escaping. By allowing air to enter the tanks, the fuel tank vent system helps maintain a balanced pressure inside the tanks. This balanced pressure ensures a steady flow of fuel to the engine and prevents the formation of a vacuum that could hinder fuel delivery. 7251. The fuel vents on many powered parachutes and weight shift control aircraft are located A. In the fuel cap. B. Adjacent to the crankcase breather. C. In the fuel tank pressure relief valve. The correct answer is A. The fuel vents on many powered parachutes and weight shift control aircraft are located in the fuel cap. In powered parachutes and weight shift control aircraft, the fuel tanks are typically equipped with fuel caps that serve as both the access point for refueling and the location of the fuel vents. The fuel caps are designed with integrated vent systems that allow the tanks to equalize pressure as fuel is consumed. 7252. Combusted fuel is expelled from a two-cycle engine through an A. Exhaust valve and exhaust port. B. Exhaust valve. C. Exhaust port. The correct answer is C. Combusted fuel is expelled from a two-cycle engine through an exhaust port. A two-cycle engine, also known as a two-stroke engine, is a type of internal combustion engine commonly used in small power equipment such as chainsaws, trimmers, and outboard motors. Unlike a four-cycle engine, which has separate intake and exhaust strokes, a two-cycle engine combines these functions into a single piston stroke. During the operation of a two-cycle engine, the fuel-air mixture is ignited in the combustion chamber. As the piston moves upward after combustion, it compresses the remaining exhaust gases and forces them out through the exhaust port. The exhaust port is an opening in the cylinder wall that connects the combustion chamber to the exhaust system of the engine. 7255. Air-cooled engines dissipate heat. A. Through cooling fins on the cylinder and head. B. By air flowing through the radiator fins. C. Through the cylinder head temperature probe. The correct answer is A. Air-cooled engines dissipate heat through cooling fins on the cylinder and head. Air-cooled engines rely on the flow of air over the engine components to dissipate heat generated during operation. The cooling fins are thin, protruding metal structures attached to the exterior surface of the engine cylinder and cylinder head. These fins increase the surface area exposed to the surrounding air, facilitating heat transfer. As the engine operates, heat is generated due to the combustion process and friction between moving parts. The cooling fins increase the surface area available for heat exchange, allowing air to flow over them and carry away the excess heat. The air absorbs the heat from the fins and dissipates it into the surrounding environment.